Yes, good morning, guys. So after a long time, we are doing a video on chemical bonding. So this video is regarding bond order. So here I will give you some techniques how to calculate the bond order. So based on these techniques, you can calculate the bond order easily. So this video is mostly useful for the people which are preparing for JEE and NEET. Okay, now? So here we have some shortcuts to calculate the bond order. Okay. So before going to this video, what is mean by bond order? So the bond order, what we can define? So the bond order is number of bonds. So between the atoms is called as bond order. Suppose if you see this is carbon monoxide. So between the carbon and oxygen, what is the bond order? So between the carbon and oxygen, we have three bonds. So the bond order of carbon and oxygen, the bond order between carbon and oxygen is 3. So like this, we can say the bond order. So let's start our video. So what is the bond order? So bond order. So the first one is bond order. So how can we define this one? So this is number of bonds between two desired atoms. So that means between what atoms you want to know, between two desired atoms. So that is called as bond order. So the bond order may be integer or may not be. It may or may not be an integer. May or may not be integer. And here remind one thing. So just you have to remind one thing. Suppose if the bond order is equal to 1. So blindly you can say no resonance. Blindly you can say no resonance. In general, if the bond order is not equal to 1, so then there is a resonance is there. Okay, so if the bond order is equal to 1, then no resonance. If the bond order is not equal to 1, so then the resonance is possible. Just keep it in mind. Okay. And how we can calculate the bond order? So here I will give you the first method, how you can calculate the bond order. So the bond order is equal to 1 plus number of pi bonds by number of sigma bonds. So this is the one method. Okay, so what is the bond order? So bond order is 1 plus number of pi bonds plus number of sigma bonds. Okay, so this is the method. Now let me see. We'll do some examples on this one. Okay, for example, I am taking CO3 2 minus. CO3 2 minus. Just write the structure of this CO3 2 minus. So the CO3 2 minus structure will be like this. So this is the structure of CO3 2 minus. Okay, so now what is the bond order between carbon and oxygen? So what is the bond order between carbon and oxygen? So now this is the question. Okay, so to do this one, so what is the bond order? So what we said, so the bond order is equal to, see how many sigma bonds and how many pi bonds we have in this structure. Okay, so between carbon and oxygen. So we have how many pi bonds and how many sigma bonds. So see here we have only one pi bond. And how many sigma bonds we have? 3 sigma bonds. So let's substitute these values. So this is 1 plus number of pi bonds is equal to 1 and number of sigma bonds is equal to 3. So this is going to get what? So 3 1 ja 3, 3 plus 1 4. So the bond order is equal to 4 by 3. So this is the one method how to calculate the bond order. And one more method, this is bond method 2. So according to this method, how we can calculate the bond order is, so the bond order is equal to number of bonds between two atoms. So what are the two atoms? Between what you want to know the bond order? Between two atoms in all resonating structures. in all resonating structures. Divided by total number of resonating structures. Total number of resonating structures. Resonating structures. So this is the second method. Let's see by taking the same example, CO3 2 minus. So we'll calculate the bond order based on this second method. So now I am going to write the resonating structures of carbonate ion. So this is one resonating structure. So here we want to calculate the bond order between carbon and the oxygen. So whenever this electron migrate like this and this electron will migrate like this. So now the structure of carbonate ion is like this. Okay, and so whenever this migration of electrons will be takes place like this. Okay, so whenever the migration of electrons takes place, then okay. So here, suppose this electron migration like this. So here we got this one. Similarly, we got like this. Okay. So how many resonating structures we have? So here we have 3 resonating structures. 1, 2, 3. So now we want to find out the bond order between carbon and the oxygen. So let's count the number of bonds between carbon and the oxygen. So here I have 1 bond and here I have 2 bonds and here I have 1 bond. Between this carbon, this oxygen I am counting. Okay, so as these 3 are the 3 resonating structures we have. Okay, so how many bonds between carbon and oxygen? 1, 2, 1. So total number of bonds is what? Total number of bonds is 4. And total number of resonating structures, how many resonating structures we have? So we have 3 resonating structures. So the bond order is 4 by 3. So in the first method we got the bond order is 4 by 3. The second method also we are getting the bond order 4 by 3. Similarly, so let's take a famous example, benzene. So okay, so what is the bond order of carbon in benzene? Okay, so let's see what is the bond order of carbon in benzene. So what is the bond order? So coming to the first method, what is the first method? So the bond order is equal to 1 plus number of pi bonds by number of sigma bonds. So okay na? So this is the formula according to first method. Now see how many number of sigma bonds we have in the ring. See, between the carbon we have to count. Don't go for hydrogens. Okay, don't go for hydrogens. So as we are counting the bond order between carbon and carbon, so that's why. So how many pi bonds and how many sigma bonds we have? So 1 plus. How many sigma bonds we have? How many pi bonds we have? First see how many pi bonds we have. 1, 2, 3. So this is 3. And how many number of sigma bonds we have between carbon? So this is 1 sigma bond, this is 1 sigma bond, this is 1 sigma, this is 1 sigma, this is 1 sigma, this is 1 sigma. So that means 6 sigma bonds is there. So now what we are going to get this one? 6 1 is 6, 6 plus 3, 9. 9 by 6. So what is the bond order? So the bond order is 1.5. Let's apply the same thing with the second method. Okay, so according to second method is what? So the number of bonds between two atoms by total number of resonating structures. Okay, so according to second method, see, this is the one resonating structure of benzene. Okay, if the electron migrate like this, we will get one more resonating structure. This is the one more resonating structure of benzene. Now see, between the carbon, how many bonds we have? So I am taking this carbon, 1, 2, and here also 1 and 2. So between first carbon and second carbon, I have 2 bonds. Plus, And between first carbon and second carbon, I have one bond. So that is 2 plus 1. Total number of bonds is 3. And how many number of resonating structures I have? I have 2 resonating structures. So this is nothing but 3 by 2. So that is equal to 1.5. Okay. Okay. So similarly, if we see, the bond order of CO2, what is the bond order of CO2? So what is the structure of the CO2? So the structure of CO2 can be written as what? The structure of CO2 can be written as, so this is the structure of CO2. And what is the possible resonating forms for this carbon dioxide is, this electron can migrate like this and this electron can migrate like this. So what it will give? It will give O positive, O triple bond C, O minus. Okay. And what is the next resonating structure for this one? So the next resonating structure is O minus C triple bond O plus. Okay, now. So now see, among these 3 resonating structures, so this is not having charge. Okay. Now count the number of bonds between carbon and oxygen. Okay. So here between the carbon and oxygen, here we have 2 bonds, and here we have 1 bond, and here we have 3 bonds. Total number of bonds is how many? So the total number of bonds is 6. And resonating structures is what? So the resonating structures are 3. So what is the bond order? So the bond order is equal to 2. See, by seeing that one also you can say, so the number of bonds between 2 atoms is nothing but 2. But what I'm saying, by using the resonating structures also you can do. You are getting the same thing even by using the resonating structures also. Okay. Okay. So like this, I will give you one more method how to calculate the bond order. So according to this method, so this is method 3. So in this method, what is the bond order is? So the bond order is equal to valency of bonded atom. Valency of bonded atom. Bonded atom plus charge, whether it may be positive or negative, whatever it may be, plus charge by total number of bonded atoms. Total number of bonded atoms. So now I am taking the same example, our carbonate ion, CO3 2 minus. So here, what is the bonded atom? So the bonded atom is oxygen. So what is the valency of oxygen? So the bond order is equal to. So the valency of oxygen is 2. Valence is nothing but combining capacity. So the combining capacity of oxygen is 2. And charge is, what is the charge here? So the charge is minus 2. And total number of bonded atoms. How many atoms are bonded? 3 oxygens are bonded. So by 3. So this is nothing but what? So 3 2 is 6. Okay. So 3 2 is 6. And 6 minus 2. What you will get? So 6 minus 2 by 3. So this is nothing but 4 by 3. See, whatever the value you got by using first method, second method, and third method, we are getting the same value, the bond order is. Okay, so what is according to first method? According to first method, so the bond order is equal to what? So the bond order is equal to 1 plus number of pi bonds by number of sigma bonds. This is the first method. And in the second method is what? So the second method is depends on number of bonds between resonating structures by number of resonating structures. So this is the third one. Sorry, second one. And third one is valency plus charge plus or minus by total number of atoms. So this is the third method. So we discussed the 3 methods how to calculate the bond order. So based on this bond order, a question is given in previous exam. So the question is what? Compare compare the bond lengths of CO, CO2 and CO3 2 minus. So compare the bond lengths of CO, CO2 and CO3. Okay, so here we know one thing. See, as the bond order increases, the bond length will be decreases. As the bond length decreases, bond strength will be increases. So this is the relation between bond order and bond length. So that means what you can write? So bond order is inversely proportional to bond length. Now coming to this one. So what is the structure of this CO? So carbon monoxide will be like this. Okay. So what is the bond order for 3 for this one? So the bond order for this one is 3. And coming to carbon dioxide. So this is the structure of carbon dioxide. So what is the bond order between carbon and oxygen? So the bond order is 2. And carbonate ion. So we know the bond order between carbon and oxygen. So that is what we got. So this is 4/3 we got. So what is the bond order? What is the order of bond order? So the order of bond order is CO3 2 minus is less than CO2 is less than CO. Then what is order of bond length? So the order of bond length is reverse of this one. CO3 2 minus is more than CO2 is more than CO. So this is the order of bond length. Okay. Similarly, take one more example. So one more example I am taking arsenate ion ASO4 3 minus. Okay. So what is the bond order between sulfur and oxygen in this case? I am using this one. I am using a method which is the third method I am using. So valency of bonded atom plus charge plus or minus by total number of bonded atoms. I will use that one. Okay, so according to this one, so what is the valency? What is the valency of oxygen atom? 2 plus. What is the charge here? 3 minus. That is minus 3 by total number of atoms bonded 4. So this is what? 4 2 is 8. 8 minus 3, 5. So that is 5/4. So the bond order between sulfur and oxygen is 5/4. So like this, we can calculate the bond order of various molecules. Okay. Hope this video is understood. If you like this content, please like, do, share. Okay. So thank you.